What's up, First LEGO League challengers, and welcome back to the FLL video series playlist for robot design and strategy. In this video, we'll be going over how to build a simple robot base, complete with sensors and motors. Your robot base will be made up of the pieces that you receive in your kit. Teams will need to purchase the kit that they want to use, be it the EV3 or the Spike Prime kit separately. The main component of your robot base will be the EV3 brick. The brick is where you will run all of your programs from, and it is where you will upload all of your code. The two large motors on the bottom of your robot will be primarily used to control your robot's wheels and help your robot base move across the game mat. As you can see, the kit has a lot of pieces. To build a simple robot base, we will only need the pieces shown. These include one EV3 brick, 3 large motors, 1 medium motor, 2 color sensors, 1 gyro sensor, and many other small LEGO pieces. Now, we will show you how to build a simple robot base. First, you want to connect your motors together using a square plate. The plate should go in between the 2 large motors, and you want to use blue long pegs in order to secure your large motors to the H plate. Next, you want to connect your motors together in the back using a long piece, so that your large motors do not shake while driving across the mat. If this happens, it has the potential to throw off your entire code. Now, you want to thread an axle through each of your large motors. This will be where you will place your wheels. You will also want to put gray bushings on either side of the large motor, so that your axle does not fall out of the large motors. Now, place your wheels on the outside of the large motors, and place more yellow bushings on the outside of the wheels to make sure that the wheel does not fall off the axle and roll onto the competition mat. You will also want to place a ball caster which has a metal ball inside at the back of your robot, which will give your robot much more freedom to turn. Lastly, we will be focusing on the most important part of your robot, the brick. Place 2 L-shaped pieces on the side of your brick and hold them in place using black pegs. Then, use the long curved L-shaped pieces along with the black and blue pegs to secure the brick to your base. Now, we will be showing you how to add more motors and sensors to your base. Here, we can see a video of our robot up to this point. So far, we have connected the 2 large motors, the wheels, and the brick. Now, we will be adding attachment motors and sensors, which can make completing missions a lot easier. As you learned in the previous video, color sensors can be used to help your robot align to lines on the mat and increase your chance of completing missions. Gyro sensors can increase the accuracy of your robot's turning, and both are extremely useful. You will want to place your gyro sensor on the back left of the robot and hold it in place using black pegs. You can also use 2 L pieces in order to place the 2 color sensors in front of your robot, right next to the wheels. You want to place the color sensors as close to the ground as possible. This way, they will get a much more accurate reading. Next, if you want to build attachments in order to complete missions, extra motors are going to be extremely important, as they will control the attachments. You can place another large motor on the back right of the brick using a square plate for added stability, as the large motor is pretty heavy. You can use black pegs to connect the square plate to the brick and the large motor to the square plate. However, if you want an attachment that needs to be extremely precise, the medium motor is the best choice. You can place the medium motor using the contraption below, which consists of 2 long blue pegs, 2 gray connectors, and 2 red converters. You can place these on the L piece connecting your color sensors. Here, we can see a video of our robot built up to this point. So far, we have attached the 2 large motors, the wheels, the brick, the attachment motors, and the sensors. Your EV3 brick has 8 different ports. 4 of them are numbered and 4 of them are lettered. You will be plugging your sensors into the numbered ports and your motors into the lettered ports. It is extremely important that you follow these guidelines, because if you accidentally plug your sensors into the lettered ports or your motors into the numbered ports, they will not work. Common practices include plugging your driving motors into ports B and C, with port B commonly being used for the left motor and port C commonly being used for the right motor. You will also want to put your large motor into port A and your medium motor into port D. It does not matter in which order you plug your sensors in. However, they all need to get plugged into your brick. Otherwise, they will not work. Here we can see a video of our fully finished robot. We have attached the 2 large motors, the wheels, the brick, the large motor, the medium motor, the 2 color sensors, the gyro sensor, and we have finished all of the wiring. The base that we have constructed is a perfect example of what your base can look like, but of course, depending on the following constraints and many more, the shape of your base can change. These factors include maneuverability. Does your robot need to fit in tight spaces? If so, consider reducing the width of the base. Height. Do more motors and sensors need to be positioned towards the bottom of the robot, under the EV3 brick? Speed. Does your robot need the extra weight from the other large motor, or does your robot need larger wheels to cover more ground? Precision. Does your robot need to be slow and methodical, or can your robot afford to be off by a little bit? Of course, these are only some of the constraints, not all of them, so feel free to brainstorm more. You can follow along this video and build the base step by step with us, and use it as a training base to learn how to build attachments and programs. During the season, you should look back at these constraints and determine whether or not you want to change the layout or shape of your base. Thanks for watching. Also, don't forget to like and subscribe, as this helps FLL teams just like you find help that they need.